Okay, let's go ahead and get started. Our next speaker is Jason Montgomery. Jason is currently a cybersecurity engineer team at American Electric Power. Okay, actively engaged in working in grid smart projects. Jason is a software security consultant, programmer, and information security practitioner. Over the years, he's consulted in a wide range of software and security projects for internet startups, Fortune 500 companies, and government agencies, including Department of Defense. He has over 15 years of software development experience. Additionally, he teaches courses on software security at SANS Institute and is the lead author of 2 SANS Institute courses in security.net development. Everyone give Jason Montgomery a hand.
So what I'm going to talk about today is defending applications from XSS, and I usually give presentations to software developers. So this is, do I have any developers here at all? So a few, good. But I think this is really beneficial for any security practitioner anyway, because at the end of the day, we're dealing with software right across the board. Everything we're working with is written in code. All the vulnerabilities are in the code, and that's where we focus a lot of our time. And we need to spend more time with the application developers and software engineers to improve the overall security landscape. So view that with that in mind. So he pretty much did all the intros. So I'm going to skip that, and there's just to keep you, make sure you're paying attention. All right, who's heard of Lawrence Lessig? All right, so quite a few of you. So he's an American academic, and he's also a political activist. He's also was one of the original board members of the Electronic Frontier Foundation, and he asserted this statement in his book Code and Code 2.0 that code is law. And his whole premise here was that much like statutory law as it's written, as it applies to laws in our civil society, in the same way, the way that systems interact, the way we create software, the way we engineer it to communicate and move information from point A to point B, that code is the law in the sense that constrains whether information is shared or whether information is protected. And it all comes down to the code. So in the software terms, that really makes all software developers, in a way, a type of legislature, right? So they get to pick and choose how they construct this code. There's not a lot of standards around it. They kind of do what they think is best. They don't have a lot of training in security. In fact, they have often very little to none. And really, at the end of the day, they're just trying to move information around, right? And so they don't have a lot of protections. Well, much like loopholes in our laws that we have that people can take advantage of them and skirt them and get around them, that's all attackers are really doing, is they're finding holes in the software and they're circumventing them and getting around them. It's the same thing. So who's vulnerable? And a lot of you will be very familiar with this already since you're in information security. But it's important that we talk about this anyway, especially when talking about software development. So Veracode, who they have static code analyzers, they write and do software code analysis for vulnerabilities. They had a State of Software Security report in 2011. And when first tested, more than half of all applications fail to meet acceptable security quality, and more than 8 out of 10 web applications fail OWASP top 10. Who's familiar with OWASP? All right, so it's the Open Web Application Security Project. They've released the top 10 most serious risks on the internet. Some of those being, injection, cross-site scripting, those sorts of things. So I'm going to talk a little bit about one of those. But that's a huge number. How many of you do web assessments at all? All right, and do you typically, does this seem to line up with what you're seeing out there pretty well? Yeah. What do you see most often? Which types of vulnerabilities? SQL injection? Yeah, what else? Cross-site scripting. Yeah, those are the big two, and that's number 1 and number 2. So that's the same thing I see. I just did an assessment just last week for a large university, and this was their identity management system. And right on the login page, cross-site scripting, you can send the payload the link very easily, hex and code if no one would know the difference, and you could basically take over the machine, put keyloggers on, whatever you want.
What are they using for identity management? I'm curious.
Well, this was a custom front end.
Oh.
So, yeah, they were using it to integrate and manage all their students into lots of different systems. So it was a custom-built front end. And a lot of the ones that have been released, actually, those also have vulnerabilities in them as well. At where I'm working now, we ran into one that, in earlier versions anyway, because we weren't running the latest, they had cross-site scripting vulnerabilities in their identity management system too, which is a pretty big deal. So that's where all the information is. White Hat Website Security Statistics Report this winter. They released this report about serious vulnerabilities in web applications. We have overall, on average, 230 vulnerabilities per application. Banking doing a little better, right? They have more vested interest to protect their information because it's money, usually around that. Education's 80, financial services, these guys aren't doing so hot. And then you move over to retail, and if you've ever worked in a retail environment, that might make sense to you. I have had a little bit of insight into one or two, and it's not pretty. Because they're really into just moving products. They really care less about security at the end of the day. So maybe they're just more risk tolerant. I'm not sure. In that same report, they broke down overall industry, and those number of vulnerabilities that we saw there in the bubble chart before is in this column. And then windows of exposure is also an important factor to look at. And you look at overall, there were 233 days of exposure on a lot of these vulnerabilities, of the ones that were found. Now, if a lot of these are using scanners or automated vulnerability scanners, they really only find a very small percentage of vulnerabilities. In fact, they're really not all that reliable. And what, unfortunately, a lot of organizations do is they scan the site, they send the list back to developers. Developers just pick off every item on that list, and then the app is fixed and secured, and they roll it out to production. When really, there's really a ton more behind it. So what are some challenges to secure applications? What do you guys think?
Retrofitting legacy apps to
Right.
have security.
Right, good, yeah. Retrofitting legacy apps, right? Because they're really not designed for security. Any other things you've run into? Sanitizing data, right. So maybe the developers aren't sure how to do it properly, or they're just not really thinking about that so much, or they're doing it wrong, right? What else?
With the scanners,
Yeah.
you use to scan code. Fortify is an example.
Uh-huh.
Part of the problem that we have is when the code is scanned, and then we sit with the developers and go over what needs to be fixed.
Right.
And then they do their tweaking, fixing. Then Fortify comes up with new signatures.
Yep.
And then we do a scan to see what's fixed, and we come up with, false positives and additional vulnerabilities that should have shown up in the
Right.
previous.
Yeah. So right, you have a moving target.
Constantly fixing code.
Yeah. Right, and that goes back to kind of the fundamental problem, is that really no amount of code scanning and going back and fixing it is going to really improve our overall application security. And that's exactly what you're saying.
Right, so the question is, how do you create a cycle where you're not constantly fixing code, or you're always behind
Right.
and trying to...
Yeah, that's a great question, and hopefully I'll touch on that a little bit for you. That is the million-dollar question.
It's a real problem.
It is, yeah.
You're constantly showing, like on my reports for vulnerabilities, I'm constantly showing that we've got risk that we need to mitigate.
Right.
And I can never get it right.
Yeah.
And that happens with any vulnerabilities. Yeah.
Well, that is true, but in DOD, you need to show that you're mitigating those
Right.
risks.
All your Cat 1s and Cat 2s.
So
Yeah. And in fact, I helped install Fortify at one government agency, DoD agency. And
you know what I'm talking about.
I know exactly what you're talking
Okay.
about. Yeah. It's tricky. So yeah, there's some challenges for sure. So the very fundamental one, really, is that the business is driving the development, right? The features that the app needs to achieve, not security, right? The non-functional requirements. And those are usually very loosely defined or not defined at all. And that's really as it should be, right? I mean, the business is driving what the features need to be in order to create a functional site that users can use so that we can be profitable, make money, achieve the mission, whatever, what have you. But security and non-functional requirements need to be taken into consideration, in fact, very early on in the process, not all of a sudden at the end of the development cycle when it's time to scale. Market forces, Guy Kawasaki, right? Don't worry, be crappy. He released the first Apple operating system without any software, right? He just said, don't just get it out there. We don't care. Everything now is in perpetual beta. That's how we live. The software is sort of tested, but really everyone's our testers. Google has perpetual beta, Microsoft, everyone else is doing this new sort of thing because everyone wants to be first. They want to get market share. They want to get their apps out on the web. So you have that sort of market forces working with this as well. This is probably one of the biggest, is knowledge gap, right? And when you talk to people in management or in higher levels, you hear a lot of these types of statements. Well, our developers are pretty smart. I'm sure they've got the security covered. Great. Anyone ever heard that? Yeah. I'm sure our developers do amazing things. They probably understand these issues, same kind of thing. We haven't been hacked yet. Anyone heard that? It's like, well, how do you know? If you're not measuring or if you have no knowledge and information, how do you know you haven't been hacked? You don't.
Still money in the bank account.
What's that?
There's still money left in the bank account.
Right. Well, there's some signs, I think, right? For sure. Constraints, right? The developer's life cycle is very short. It's fast. Everything's agile now. Well, not everything, but a lot of things are agile. And really, they only have time to get the features in that they have. It's very expensive to roll out a very formal program for software development lifecycle. And it takes a lot of time, resources, energy, education. So it's difficult. And there may be some, again, more knowledge gaps. We don't have anyone here who knows how to do these things, right? How do we figure that out? Again, those are some constraints we deal with. And the bottom line is there's usually no process to incorporate security in a lot of ways. And what I mean by that is that security gets involved up front at the beginning. There needs to be a maturity model around the software security lifecycle as we roll code out, as we produce it. There's got to be gates, there's got to be steps that are followed from inception, right, so that everything's not thrown together, architected. The authentication's not architected, then you roll it out to production and realize they didn't do session management right, and they have to rip out the guts and replace it, right? So you have to have a lot of those things in place up front. You have to have standards, guidelines, governance, accreditation, and certification that allows apps to go to production, go, no-go kind of thing. There's a couple maturity models. BSIM, the Building Security and Maturity Model. You can find this, Department of Homeland Security links to this. And then there's the OISF Software Assurance Maturity Model as well. And both of these have some good ideas to help. And then Microsoft, of course, has their security development lifecycle as well. But again, these can be pretty heavy. They're hard to roll out. But at the end of the day, this is probably more of what needs to happen in our organizations. And within these are a lot of things such as the governance steps and the education steps and things like that. So I would recommend taking a look at some of these if you're having trouble. Yeah.
How many larger companies or organizations that do the code development is using these kinds of models? I mean, when I looked at the statistics and I was looking at a document, I can't remember the name of the gentleman that wrote it, but he was saying that there are only a handful of people in the U.S. that really know how to put a process together to make sure that the code is not vulnerable.
Well, I think there's a few people doing it. There's not a lot of people doing it. You cannot find good software security architects. It's very difficult. I was between jobs, I don't know, a few months ago, 4 months ago, and I was in a job interview for a large software consulting company, a very large one, and they were like, well, you do software security. They're like, that's cool, but we need an architect. And, we do security. We authenticate users. We do role-based checks and stuff. And I'm like, I don't think you understand what I do. So there was just a fundamental, complete misunderstanding about what software security even is.
There's not that many people that really understand.
Right. Yeah, and there's not a lot out there. So looking into these, and really these have all the guidance you need, because someone can't necessarily come into your organization and make this happen because they don't understand the culture, the requirements, the regulations, and all those things. So typically...
OWASP is really good.
Yeah, the OWASP stuff's good, and then I really like this one as well. So I would recommend taking a look at either one of these, and maybe pulling from both, and sort of to build a software security program. And that's part of what I'm doing at AEP right now, as well as helping them build one of these. So, and at the end of the day, right, we have 6 billion crash test dummies. This is a quote from my colleague David Rice at Sands, who's now Apple's global security officer. So hopefully he'll be making some changes over there, but everything went dark as soon as you started working there. So I don't know anything as much as anyone really. So, but yeah, I would recommend this book, Economics: The Real Cost of Insecure Software. If you really want to understand and try to make the case to upper management and executives about software security, this book really sells the economics and how it's sort of the fundamental of our modern day infrastructure in society, much like roads were, a long time ago for us to move products around. Now it's the internet. So, but yeah, he asserted that we're basically like 6 billion crash test dummies. Everyone's being thrown up against these websites, and they're broken or they've not been tested very well, and so all of our information is essentially at risk. And if you've probably heard about the Sony fiasco over the last few months. And those were all very basic SQL injection vulnerabilities, cross-site scripting, and it was just one after the other across their entire enterprise, across the world. Like, it was nonstop. Affected their stock price, cost them millions and millions of dollars in damages. So maybe billions, hard to say. So it's a big problem. So software insecurity, right? Let's talk a little bit about that. We have the common weakness enumeration. Who's heard of CWE? Okay, who's heard of CVE? Okay, usually a little more. So anytime you get a patch from Microsoft or Apple or anything, when there's a vulnerability, it gets in the common vulnerability enumeration, or CVE, right? There's all those numbers at the bottom of the patch that talk about where the vulnerability was documented. CWE is an attempt to create a taxonomy and a way to categorize and organize software weaknesses. So that instead of coming in after the fact and saying, well, here's all the vulnerabilities we found, they said, well, let's move a step back and let's define all the weaknesses first. And then developers can work from the weaknesses and try to shore up their code as they develop, so we're not coming back later trying to patch. And that's kind of where these top 10 or top 25, top X lists came out. OWASP has their top 10 most critical web application security risks, and CWE SANS came up with the top 25 most dangerous software errors, right? So these, again, are going to enumerate the stuff that we're seeing a lot of, that have been around forever, and still there's a gap with developers on understanding these issues, and so the software still has a lot of problems. So why are these lists important? One, raise awareness and education. Those are huge. Developers, again, are not formally trained. You don't go get a license to be a developer. Anyone can throw code on the internet. You can be whatever age that you can to learn to program, and you can be putting stuff out there. And it's really easy to make mistakes. Software frameworks are getting better at protecting the developer from themselves. But in a lot of ways, you can really create all kinds of problems for yourself, security-wise. Industry accepted mitigation techniques. This is huge, right? Developers love to go solve problems usually, right? So you run into a problem, you're like, oh, there's this vulnerability, it's cross-site scripting, I get this. And you go, they write a code, they're going to encode the data, right? Well, they didn't understand there's actually 6 different contexts for where you need to encode the data, and that the encoding changes every time. So they only coded for maybe 1 or 2, which means they've only fixed a small subset. So again, we need to go back to the industry and talk to everyone and see what they're doing to figure out, well, what is actually working, what covers the whole problem. Yeah.
One of the things I have found, too, is that developers that I work with, they don't understand not only the security side of it, but when they make mistakes with code and they have vulnerabilities, then you have a web server that has a horrible backend, and what can happen?
Right. Yeah, again, it's...
They don't understand the implications of that.
Right. Yeah, again, they're not right. They're really good at what they do, and that's write code, but there's this whole security aspect of it that's sort of missing. And that's where education and awareness really are huge. And so I usually do this presentation with some demos, and usually, like I just did at the Microsoft Star Trek in Columbus, the Microsoft conference, and it really gets a good rise out of them. And they realize, oh, there's a problem here, because they didn't realize I can completely compromise your machine with a simple cross-site scripting vulnerability. Or that with an Oracle database, if it's got the HTTP stuff enabled in the back end, I can do SQL injection in the login screen and start making web requests in the back office, right, which I've done before in vulnerability assessments. So, yeah, it's important. Collaboration, common terms and language, right, so we all are talking the same terms. Cross-site scripting versus cross-site request forgery versus clickjacking versus one-click attacks, right? And even sometimes there's some confusion, but you get the basic idea of what people mean. And you can go look it up, right? It's well defined. And at the end of the day, we need to make security measurable. And then once we can make it measurable, we can prioritize, right? If we can't prioritize, we've got this giant problem to fix, and we're not real sure what to focus on first. So if you consider, CWE defines 658 software weaknesses. Did anyone even consider that there might be that many weaknesses you could introduce into an application? Okay, that's a lot. So it goes to the problem of, well, I really need to prioritize now because I can't deal with all these. And we're not really looking to make things 100% secure, right? We want to make it defensible. We want to reduce the level of risk to an acceptable level, right? That's what we do in security all the time, right? It's not about 100% security. It never was. We don't have the time or the budget. So the OWASP top 10, briefly, injection, cross-site scripting, which is really just a type of injection, right? But it's so prevalent, they pulled it out, made it its own bullet point. In fact, most sites I look at still have cross-site scripting, just all over the web. It's very common. Broken authentication and session management. This actually is a more difficult problem than one would think. Doing session management properly, authenticating users properly, doing it consistently is really difficult as well. Cross-site request forgery and insecure object reference are related. If you go directly to an object or a page and the security authentication has been enforced there, you get to it because the developer didn't wrap the security context around the objects properly. Cross-site request forgery is an identity problem. We can't really tell who was making the request. Was it the user or was it someone through another tab in their browser through an injectable cross-site scripting vulnerability? Then we have misconfiguration issues, cryptographic storage. Crypto is a huge problem. Developers get this wrong all the time. I just saw an app where they had implemented, what's it called, where you got to put the license key in, right? And then it unlocks the app, right? Well, they had stored the keys right in the binary. So it took about 2 minutes to figure out how they had implemented their licensing mechanism to purchase the application. So 20 lines of code later, paste in the key, the app's full of unregistered use, right? Cryptography is hard to do correctly, especially when storing keys and whatnot. Failure to restrict URL access, again, this is kind of like in secure direct object reference. Insufficient transport layer protection, right? That's data over the wire protection. And unvalidated redirects and forwards. I see this one a lot. A lot of redirects and forwards are done through JavaScript. They're usually injectable. They're not usually managing where the outbound site is. I see this one a lot too. So I just want to focus briefly on cross-site scripting. Usually one I illustrate to developers a lot, and it's pretty effective. And I think it makes the point about injection pretty well, really across the board, because injection is injection is injection. It doesn't matter what kind it is. It's all the same principle. And there's really two main things we do to protect it. But CWE defines cross-site scripting as the software does not sufficiently validate, filter, escape, and/or code user-controllable input before it is placed in an output that is used as a web page and served by the user. Basically, we inject stuff, we rewrite your laws to do what we want. Is really all that means. Taxonomy, right? I said CWE is a taxonomy. So at the top root, and there's actually a few above this one, but CWE 20 is improper input validation, and it's a category, right? And these are all affected by that lack of that control. Then we have injection, which is a broad class, and then specifically we have a base of attack under that called cross-site scripting, and then under that we have a bunch of variants. We've got basic XSS, improper sanitation and error message, improper neutralization of the script and attribute, URIs, double encoding, just a bunch of variants, right? And there's really three main types of cross-site scripting, right? We have stored cross-site scripting. That means you persist it back into the database. That way, it basically lives in the website. So when other users come by and browse the site, it pulls that attack out and renders it on the page for the other visitors and attacks them then. Reflected is basically when you put it in a link, you attack in an email, you email it out in a link, or you embed it in a web page. They click on it. The server takes that link, does some manipulation, and then ends up reflecting the attack back out to someone else. So you might use this in a phishing attack or something like that. And then DOM-based is really a specific type of reflected XSS that really doesn't ever have to go to the server. It all really happens on the client in JavaScript. All right. So here's a reflected example. We have a URL, site.com, error SPX. This was that one variant I had mentioned briefly. And then we have %3C script, %3E alert, tick XSS, %3B, %3C script. So, and then in the code, in our ASPX page, say we have a .NET application. The developer will write %equals, which is going to evaluate this function and return the variable message from the query string and embed it into the web page, right? So we're going to take this JavaScript and just inject it blindly into the web page. And so anything anyone puts on the URL will end up in here. Now, a lot of people like to show the alert boxes, which really aren't that scary at all. In fact, they're benign. It's really the other things that you can put up here that are the problem. It's the attack payloads referencing external scripts and things like that, which I'll show later in the demo. So the output HTML then ends up with code embedded into the HTML page, right? We injected this malicious code into the browser. So context matters. I alluded to this earlier, right? We have different places, and when you're doing an assessment on code, and I typically don't like to use a scanner, so I like to look at code because I'm a software developer. I can tell way quicker if there's problems just by looking at a few pages in the website, because it's usually through the whole thing, right? Because part of the problem is they're not fixing these issues consistently and in a central way, and that's what's going to help. So we have web. In particular, we have HTML entities, right? Or HTML elements, I should say, not entities. We have the attributes, right? Those are the things that are like, so if we have a style attribute on a div tag, right? The style is the attribute. We can inject code into the style potentially. We can inject into JavaScript, URL, or CSS. I'll give some examples of these. Some of the injection points. So if we're going to inject into an HTML element, right? We have our div tag, and then we're embedding unvalidated input in between the div tags we're putting an element in between another element, right? Attributes are where we inject code inside of the tag, right? And then the comments is another type where we can inject and actually override things. So things aren't safe just because they're in a comment. JavaScript, I see this a lot. This is a redirect, that last one I showed on the OWASP top 10, where they take the query string location off and then redirect the user to that. So a lot of sites will have, you're leaving our site now, just so they're aware, and then it'll redirect them to that page. This is kind of what the code often looks like, and this is vulnerable to hijack. And then within style sheets or in style tags, again, we have different contexts here. And then within URLs, we can embed values. And all of these different HTML entities, for lack of a better term, have different encoding requirements, right? So we can't just HTML encode everything, because that's not going to save us. And I'll show you why. Oh, and before I go into that, I was looking at a forum on slackers.org. And they basically said, hey, let's just go find cross-site scripting vulnerabilities everywhere and post them. So they just went through the internet and it was just like, it was really easy. So PhotoBucket, HP.com, Ninja Proxy, Dell.com, PC World. It's everywhere. Everywhere. Did you guys see this one? End of last year. This guy, this Australian teenager, disease app, or Pierce Delphin, he was looking at Twitter and he saw some guy had figured out how to make a rainbow pattern background on his Twitter page through injecting a style sheet. He's like, oh, sweet. So he played around and he realized he could inject an on-mouse over instead of a style sheet. And he was able, when you moused over the message, to pop up a pop-up box on Twitter. So he posted this, and then this popped up. And then you can see on this Twitter tracking system for tweets with this in it, within, I think it was within like 2 hours of him posting this, they had up to 100 requests per second with this vulnerability injecting into it, pulling it up to Twitter. They figured out how to automate it so you didn't have to do the mouse over. You could just load the page. So if something showed up in your feed, you could just do whatever you wanted. They were rickrolling people and doing all kinds of fun stuff, and then some malicious things too. Most of it was just for pranks. Twitter fixed it pretty quick after. And again, Facebook had an issue as well, and these are wormable as well. You can get them to spread by themselves. So it's a very prevalent problem. It happens all the time. And it's getting to the point where now the browser makers are actually just embedding code to help protect users because developers aren't doing it. So Internet Explorer has cross-site scripting protections built in, which actually ended up with a vulnerability in it, which you could use to do things you wouldn't normally be able to do. Unfortunately, again, it's software, right? It's got the same problems. Chrome does it, and Firefox still doesn't seem to have any protection built in that I can tell. I haven't looked at it in depth, but
it does the 3.6.
it does. Okay.
What is the primary target of these SQL injection attacks? What are they looking to do most commonly?
With the cross-site scripting ones?
Yes.
Yeah, I will show in a demo when we're done. So the big thing we want to do, but yeah, I'll get to that for sure. That's a great question. The big thing we want to do is defense in depth, right? We need to constrain input through input validation, and we must encode all special characters, right? So if I were to create a little box diagram, if you have any takeaway point, if you're a developer or if you want to give something to a developer, there's two things you want to do. And most people only get one of these, if they do it at all. So the first question you want to ask yourself is, should I consume this, right? I have a 3-year-old son, and he'll consume anything. He'll pick stuff up right off the floor and eat it. It's just highly disturbing. He had his hand down his pants one day. It was not pretty. But yeah, kids, they don't know. They're still discovering the world around them. We have to ask, well, should I consume this, right? As developers, and as humans in general, we usually ask this question as well. But developers should ask, should I consume this? Should my application take this data in? If I should I emit this data, right? Because we have something else that may happen on the way back out. So should I consume might tackle SQL injection, but should I emit tackles cross-site scripting, right? So they happen at different points. Same with database, right? We have the same issues. Pretty much anytime you move between two tiers, you want to ask yourself these two questions, right? What if you're talking to an LDAP server, right? That is a whole different set. Distinguished names need encoded a certain way. Still, search filters need encoded a different way, right? You can't just blast on one type of encoding. And that's why we go sit down with the developer and we're like, when they don't know these things, when there's an education gap, right? They just want to fix the one thing, and they'll just kind of guess about how they should fix it. Because we're sitting with a report for security people who maybe aren't programmers some of the time. So we don't know how they should fix it. We might send them some links to OISF or whatnot. But we're really not going to know, is this mitigation really going to fix it? All we know how to do is rescan with Fortify or AppScan or something like that, which is only going to get us a small percentage of the lowest hanging fruit. So we really need to educate them and basically build up security architects within our organization for developers, which is going to take time, but that's what needs to happen. Right. So injection mitigation in general. So this is for any type of injection, right? Whether it's LDAP injection, SQL injection, XPath injection, XML injection, HTML injection, you name it, right? Injection is injection. You just assume all inputs are malicious. Use vetted libraries. Probably shouldn't write your own. You might need to in some cases, but you probably shouldn't write your own. There's probably one out there that does it already pretty well, either from Microsoft or from OWASP or from someone else. They need to handle validation, escaping, and encoding. We need to use length checks, right? And not just in the HTML page, right? It's easy enough to just put in our input box like a limit of 20 characters, but attackers circumvent the HTML, right? They're just going to work at the HTTP level. They could care less what the JavaScript validation is doing. jQuery is nice, but jQuery validation does not protect you from any security vulnerabilities at all, or any other sort of JavaScript checks. It's really for user experience, which is nice because they don't have to have that round trip back to the server to figure out the data was back. But we need to have it on both, but that also creates a problem when we test, right? We have to test it with JavaScript off so we can see that the server-side validation is doing the same thing as the client-side validation, right? So there's a lot of things to consider there. We want to use a combination of whitelists, blacklists, and encoding. You guys familiar with whitelists and blacklists? Right?
I have a question
Yeah.
about whitelisting.
Sure, go ahead.
With a custom coded web server application, we have, it uses special characters as input for like inventory.
Mm-hmm.
So you can't whitelist
Correct.
with certain special characters.
Sure. Yeah, it's very common. A lot of apps need to take HTML in, but that opens them up to cross-site scripting. But we can't not take the HTML in because, well, the business case says, well, they need to be able to bold some things and italicize some things. Same principle. Yeah, and so what you have, and that's why you use a combination, right? And you may need to encode that information so that when you present it later on, you put it back the way it needs to be for that context. But you want to be very careful about how you do that, and that needs to be tested heavily because it's easy to create other problems through this. Because if we just strip out a bunch of characters, we might collapse a longer string into another attack, right? So we need to, and then you have to recurse over it until there's no more changes or
Test the code even after you fix it to ensure that you haven't broken functionality
Right. That's right. Yeah.
of the website.
Yeah. It's definitely a challenge. Yeah. Properly encode escape data. Indirect selection is nice. That's when we can just drop down list that maps to numbers that map to actual data. So we're just validating integers is easy, where numbers is easy. So if you have a state drop down, don't pass the states in, just pass the numbers in. Know that one maps to the first state in your list, that kind of thing. And then at the bottom there is a note, take care with regular expressions, right? Because it's really easy to shoot yourself in the foot with those two. They get really complicated and done really very fast. Specifically for cross-site scripting, we need to set consistent encoding, right? You see this little chunk of code here? It turns out in Microsoft likes to help people a lot, and they wrote a nice little detection for MIME types in their page. So if you set them a MIME type of what a page content was, like you said it was UTF-8, or actually maybe you didn't set it at all, they would scan the first maybe 1 to 4K of the data, I can't remember. And if they saw anything like this, plus 80W minus, they would assume you were doing this old UTF-7 encoding, which was used in old email systems, right? Why did they figure the browser needed that function, right? Someone probably wasn't thinking that through. Like, we don't usually send pages in UTF-7 format. We send them in, UTF-8 or something else. So there's not enough space in UTF-7 to represent the angle brackets, right? So they had this special encoding that the browser would actually interpret as a script tag. So if we don't set consistent encoding in both the header, HTTP header, and in the meta tag in the HTML page, or if they don't agree, which is often what happens because the developer uses a template that comes baked in Visual Studio or Eclipse or whatever they're using, and then the web server has a different header, right? So that's a problem. And they don't match, then the browser's like, well, I'm going to have to guess or infer, right? And so they fixed this. This won't happen anymore. But it gives you an idea of what encoding problems can cause and some of the complexities there. Encode using whitelists. We'll talk about that a little more. And then we want to sanitize any dangerous tags and attributes. If you need to take in HTML, you need to take in your special characters. You need to make sure you're able to constrain and validate that those are valid and that they meet the recommendation. And that won't cause an attack somewhere else to work. And if it does, you need to fix it in that place. So it gets a little complicated. And again, if you can avoid HTML input, it's not usually realistic these days, it seems, especially with the WYSIWYG editors that come in the browsers now. You can control what tags they generate, and it's important to validate that on the server. So one such library is the Microsoft Web Protection Library. It's really their anti-XSS 4.0. This is for .NET 3.5 and above. If you're not using this in all of your .NET applications, I would recommend you look heavily at this. This is the way to go. In Java, anti-SAMI is the library of choice. It's named after the SAMI worm from MySpace years ago, and it's called anti-SAMI. This is whitelist based. You can define the allowable character set, and if it's not in that character set, it encodes it. It doesn't care if it probably will render fine on your web page. It just encodes it. There's also what's called a sanitizer class, and you can basically pass in large chunks or entire HTML documents, and it will go through and sanitize and pull out any unsafe tag that can inject JavaScript into the document. So it'll parse it and filter out dangerous information. Here's how you define. So you can go in and say, Okay, on the lower, on Unicode, right, you've got all these code charts. Unicode makes everything really complicated. And most of us here in the U.S. don't really think about these things because we're used to dealing with ASCII. But there's all these code charts that can have all kinds of extended characters. So in the anti-XSS library, you can basically say, look, basic Latin characters are safe, and some of the Latin extended additional ones are safe, as well as mathematical operators. I also want to allow currency symbols. No upper and no upper mid code chart values are allowed. So you can go in very finely, define the valid character set within your web application, and constrain the input and encode everything else. So that's important to be able to do. Then they also, remember I said context matters, they have methods for all the different contexts that you can actually have in cross-site scripting injection happen. So they'll encode CSS blocks, they'll HTML encode, they'll HTML attribute encode, URL encode, HTML form encode, JavaScript, and Visual Basic Script encode. And so all of those need to be used in the right place. So the old adage to just use HTML encode methods, that doesn't work. That only works in one context. And all the frameworks only came with one method when really they needed 6 or 7. So that's changing now, thankfully. And some of the frameworks are starting to automatically do it for the developer as well, which is good too. The less they have to think about this problem, the better. HTML elements. So here's an example. So this was before we had our request query string message coming in. All you have to do is wrap it in this method, and you're done. That fixes that. In an attribute, right, we have to attribute encode, right? So you just wrap it, encoder.html attribute, we put in our value from the URL. That's all we have to do there. Or from the database, really we need to encode anything coming out of the system. Unless we need it to render as HTML, and then that's when we need to use the sanitizer. JavaScript variables, encoder JavaScript encode, and then CSS encode. In .NET 4.0, they brought some new syntactic sugar in. Instead of the %equals to evaluate variables, they put in a %colon. The %colon says use the default encoder. Well, the problem is you can only have one default encoder, which means they miss the other 5 contexts. So again, the abbreviated syntax doesn't always work. It only works in a certain context. So you have to be aware of that. And this is basically functionally equivalent. HTML encode is basically the same as the %colon here. You can also inject your own encoding. So the default encoder in ASP.NET 4.0 is the HTML encoder, which handles one particular type. It's blacklist based. It doesn't have very good coverage. You can actually swap out the configuration file and put in a better one, like a whitelist driven one or something like that. So they've made an extensible framework for swapping out coding, which is nice as well. So this is basically adding the MVC3 Razor view engine, right? So there's this thing called Model View Controller. It's a new way to develop apps. It's kind of a REST, if you've heard of REST architecture. Microsoft has that. They've created a new way with this @ sign to embed variables. So you don't have to have this bracket %equal all the time anymore. It's a little more, it's a little lighter syntax-wise. It's nice. And a lot of that also automatically encode too. Default encoder, like I said, is a blacklist. It's only going to encode ampersand, tick, double quote, less than, greater than, and then anything between hex A through hex FF. Right? So that's the default one. And I recommend switching to the anti-XSS one from Microsoft, as it's a whitelist-based one. And anti-SAMI for Java, it's got a whole configuration. You need to go in and make sure you set appropriate whitelists for which attributes and which tags you allow as well. Right, you can swap out the default encoder. And with that, someone had asked, what can you do with anyone? What you can do with cross-site scripting. And that's really gets to the crux of the issue, right? If it's not that risky, why do we care? So let's take a quick look at a demo that hopefully will, let's see if I can. All right. Who's heard of Beef? Good, yeah, good amount of you, okay. Beef's really nice. I like to use it in demos for developers because it's quick and easy and it illustrates the point. fairly well about why cross-site scripting is a problem. And BEEF stands for Browser Exploitation Framework. It allows them to essentially automate a lot of the tasks you would do for an attack to make things a lot easier. And so what I'm running in this left VM, this is a virtual machine running Linux Backtrack. It's a penetration testing live CD or virtual machine. And I've basically loaded it up into a virtual machine. And then I have Windows XP box running. And this is going to be our victim, and the attacker is going to be over here in the backtrack. The attacker, essentially, so I built this little fake little music store. I don't want to run Chrome, I want to run Internet Explorer. All right, so what you'd normally see, imagine it's Amazon selling music CDs. It's basically what this is, a very lightweight version of. And you can go in and you can look at, customer reviews. And I've pre-baked in the cross-site scripting exploit, but you can see it's basically just a script tag right there at the bottom. Script language equals JavaScript source, and it's pointing to a script that's loaded on the attacker's machine over here, right? And so this is the malicious data. It's pretty short, it's not very long, because all of the code is in this Beef Magic JS script that's essentially, we're basically making a mashup, right? People like to merge Facebook, Twitter, and all the stuff into their website. Well, we're just merging an attack into a website. Same principle, that's how the web was designed, unfortunately. All right. So I'm going to go ahead and inject that. I have the firewall turned off. Once I inject that code, the user, any other user who comes and views this page will see a simple whatever text I put in there. What you'd see in the source, though, is that script block, right? Because the developer did not code it before it came back out. Over here, you can see we've hooked a zombie who's running Internet Explorer on Windows. So we now have interactive capabilities with this session. So what we can do is we can start to learn about the victim with this. We can see what page, we can look at the page contents. So I can just dump the HTML page they're looking at and read it. So if that had sensitive data on it, maybe I can have access to it. Many times you can also dump the cookies, things like that. Say they're ready to buy something, or maybe they want to log in for some reason. Right, so they log in. What you notice over here is there's a little keylogger installed in JavaScript, right, that hooks on all the key presses. And it's just recording anything the user types at that point. So now I have jmonty@gmail.com, and then it captured the password. Now, it's pretty rudimentary. It doesn't capture, that you moved into a different text box or anything, but you could get in with that pretty easily. It also has some other features and functionality. This one, it's got a distributed port scanner. JavaScript has the ability to make calls back out from the victim's machine. So the victim's usually behind a firewall in their enterprise or whatnot. They might be on an HTTPS connection. So all this would be invisible to anything but an endpoint security running on this machine that may happen to detect this cross-site scripting. So what we can do at that point is we can just say, you know what, I want you to scan 192.168.100.2. I'm just going to, since these are on a little virtual network together, the only two machines, I'm going to tell the victim to scan open ports on the attacker's machine. But if they're behind your enterprise firewall, you're going to want them to scan back there to see what they have access to. So I say scan the target and scan ports 8220 and 8080. Click scan. Oops. Always got to select your zombie. So you can actually have a bunch of zombies loaded and you can send it out en masse. So you hit scan over here in the log window. You can scroll down and you see module result, 8080 is open, 220 is open, and 80 is open. So now we know that this IP address behind that firewall has some ports open, all through JavaScript, right? So that's kind of a problem. They can do some recon that way. And then really the biggest thing is that they've built in I don't know if I have time. When does the session end?
You got another 5 minutes or more?
5 minutes.
5, 6 minutes.
We'll try now. I'm going to run MSF console. Who's heard of Metasploit? Use Metasploit? Okay, a lot of you. Pretty common again. Most developers have never heard of these tools unless they've had. So when you show this to them, it makes an impact, I think, pretty quickly. And they realize that, oh, maybe I do care about cross-site scripting. Like these alert boxes maybe are a bigger deal than I thought. All right, so Metasploit gets updated just like everything else, only instead of with patches, it gets updated with vulnerabilities. And we can essentially wire the two together. Run this command real quick. That way. So I've just loaded an XML RPC server in Metasploit, which basically is going to allow in a browser to interact with it and send commands, serialized objects back and forth. So then I'll go over here to my browser modules, and I can go MSF browser exploit. And it's going to just preload all the browser-based exploits for me that Metasploit has that are out known in the wild. And these often get released before we have patches. Anyone familiar with the Aurora attack last year, right? So that's been patched now, but that one got Google and some other defense contractors. So we can pick an exploit we want to send, have it listen on a port. So let's fill out some of these fields. So it's tricky. Confines of a VM. Oh, yeah, I need to pick my payload. So I can basically inject code here. So I'm going to inject meta-interpreter reverse TCP, which basically allows them to call out to me from their client. And basically, we're just going to inject a malware into their machine.
Got 120 digits in there.
Yeah, thank you. So, the path, the host to listen on. All right. And we'll see what happens. Since exploits are not they're taking advantage of non-deterministic behavior and vulnerabilities. Browsers, they don't always work. And I should just probably wrap up. But essentially what this allows an attacker to do is wrap up a packaged remote shell. There it went. And essentially what we'll see on the server side, if all goes well, so you can see this browser bar went up and hung. Now, one of two things usually happens. The payload takes advantage of the vulnerability in the browser and injects shellcode into the operating system. That shellcode then connects back to the server, like it just did, and opens a port that gives us full access to the machine, the victim's machine. So now we're running in that user's environment. The browser stays hung, and now at this point we are not confined to just JavaScript attacks in the browser, right? We've moved up and escalated into the operating system. Most users are running as administrator, So at this point, we can dump, the password database, local one, put it into Enable, and brute force passwords. We can install keyloggers. We can upload any file we want and execute it. So at this point, the client victim is fully compromised. Oops. So I need to interact with the session. Sessions-I1. All right. And then this will just give you a quick illustration of what I can do. So I just sent the screenshot command, which sent me a screenshot of their desktop. Right. So you get the basic idea. Pretty much whatever you can do in code, you can do now on the victim's machine. So the big takeaway points then, really from this are why don't you go to the end? Scroll down here. Sorry about that. All right. Really, the main takeaway points is we need to educate developers, right? They're not trained in security. They're good at what they do. They're just not good at this stuff. And maybe they're not. Some aren't good at what they do either. So you'll have that. But that's true of anything, right? Some security professionals aren't great, right? But we need to educate developers. We need to make them aware of the threats. They don't know the threats. They don't care, right? If you start telling the developer that I'm rewriting all your code and I get to play around in your website, they might be a little upset by that. They might not like that at all. So education's big, and then making sure that they're standardizing their libraries, they're doing constant education with each other. Pretty much in a lot of these maturity models, they have every project, every iteration of every project, they do some sort of security education something. Whether it's an hour, they'll talk about current threats, vulnerabilities, coding techniques that prevent attacks. They just constantly need to be working on that stuff. Just like they're looking at all the new technology that's coming out, they need to be looking at what the threats are, as well as how to mitigate them. And again, with that, over time, the knowledge will grow, and then I think we'll end up with a lot more secure things. And they also need to standardize on libraries. This, rolling your own input validation for every app you write differently, inconsistently, not centrally, is a huge problem. So things need to be standardized as well. So you need good standards, coding standards, and things like that. And then those scanners really are just checks, because we don't have time to review every line of code, right? So the scanners go back in and they say, well, did you use the libraries, right? You can customize the rules. And you can say, did they use the library that we said to encode, like in Fortify or AppScan source? And then we can validate that, yeah, they did. And then we have a pretty good feeling then, as they're doing things consistently and repeatably in the same ways, that we've probably got the biggest risks out of the way. We can relax a little bit, and then we can focus on some of the more complicated ones later. That's all I have. I'll be around a little bit. I've got to catch a flight to D.C. a little later, so I won't be around too long. But real quick, here's my contact info. Feel free to send me an email or hook up with me on LinkedIn or something if you'd like. That's all I have. Thank you.
Thanks, Jason.